It began as an ordinary observation, a drop of water filled with life too small for the naked eye. I expected to see the usual bustle of single-celled organisms drifting and spinning about, but what I found was anything but ordinary. At first, the ciliate, in my view, appeared unremarkable. Its elliptical shape and steady movement gave me no reason to think otherwise. Yet something subtle caught my eye. A delicate indentation forming right here, at the center of its body. At first, I thought I was looking at Colpoda, a genus of ciliates known for their curved, goblet-like shape with a narrowing that leads to the oral groove. But something wasn't right. As I continued observing, I noticed the indentation wasn't singular. It appeared symmetrically on the opposite side as well. That's when I paused. I scanned my mind for any known species of ciliates with such symmetry, but no answer came to me. It didn't add up. And then I realized, this wasn't a quirk of shape or a unique species. I was witnessing something far more profound, the miracle of binary fission. The ciliate was dividing, its single body methodically splitting into two. Slowly, as if choreographed by nature itself, the indentation deepened, separating the organism into halves that would soon become two identical individuals. A process so fundamental to life, yet so easily overlooked. In this quiet moment, a single cell became two. An unremarkable drop of water revealed something extraordinary. The relentless drive of life to persist, multiply, and transform, even at its smallest scale. I decided to wait and observe the entire process, the emergence of a new cell. But is it truly new? This question opens up an intriguing biological puzzle. The ciliate before us is a single-celled organism, and what we are witnessing is the division of an already existing nucleus, a process called binary fission. What does this mean in practice? Is it creating an entirely new organism? The answer is both fascinating and surprising: no. What forms here is not a completely new organism, but an exact genetic copy of the original, a true clone. During binary fission, the DNA within the nucleus is replicated, creating two identical sets of genetic material. The cell splits, distributing these copies equally. This is why it's nearly impossible to determine which of the two resulting cells is new and which is old. Both carry identical genetic instructions and are indistinguishable from one another. It's not so much a question of who came first, as it is a perfect division, life duplicating itself with incredible precision. As I continued observing, I noticed something remarkable. With a closer zoom and as the ciliate rotated, two distinct spherical structures became visible. These two halves were tightly adhered to each other, poised for the final separation. They seemed to wait, as if in silent anticipation, for the completion of their division, for the moment when two independent cells would emerge. But what happens next is surprising and unpredictable. Nature, even at the microscopic scale, follows its own rules. Rules that often defy our expectations and remind us of life's relentless drive to persist, replicate, and evolve. But before we reach the surprising and unpredictable conclusion of this division, let's briefly discuss the process itself. Where does it come from? Why does it happen? And how does it unfold? At its core, this is a process of survival and growth, a fundamental mechanism of life. Single-celled organisms like this ciliate reproduce through a method known as binary fission. It begins with the replication of genetic material within the nucleus. As previously mentioned, the nucleus doesn't simply split in half. It first duplicates its DNA, ensuring that both resulting cells will carry identical instructions for life. Once the DNA has been copied, the cell begins to elongate, and the two sets of genetic material migrate toward opposite ends. Gradually, the cell membrane starts to constrict at the center, forming the indentation we observed earlier. This narrowing deepens until the cell splits entirely into two independent yet identical organisms. It's an elegant and efficient process, driven by the ciliate's need to reproduce and sustain its population. Through binary fission, life ensures its continuity, a seamless duplication that has been perfected over billions of years. And now, as the final moments of this division approach, we return to our observation. The two halves, nearly complete, are on the verge of becoming independent. What happens next might defy our expectations, but it's a reminder that even in the smallest drops of water, nature is never ordinary. This process can take quite some time, so let's skip ahead by several minutes and focus on the heart of this extraordinary event you are now witnessing. As you can see, the familiar ciliate has almost completely transformed. It is now practically two separate organisms, joined only by a thin membrane. Just a moment longer, and the single organism we first observed would complete its division. Two identical yet independent cells would drift apart, each one destined to continue its search for food and to divide again. It would have been a perfect conclusion, a seamless duplication, a triumphant moment of life continuing its cycle. But as I mentioned earlier, life, even in the microscopic world, is unpredictable. A subtle current, an invisible flow of water, began to push this fragile organism off course. Slowly, inexorably, it drifted toward the edge of the glass slide, a boundary it cannot escape. Here, at this unforgiving edge, the process of division halts. A single organism, so close to creating two lives, now faces an abrupt and irreversible end. And so we observe, not the triumph of life, but its fragility, a reminder that even the most fundamental processes are shaped by chance, by forces beyond their control. In the microcosm, a shift in the current can decide the fate of a life. It's humbling to witness, to realize that survival, growth, and even existence itself are never guaranteed. From the smallest cell to the largest organism, life is delicate, vulnerable, and yet it persists, finding ways to endure. This moment, though tragic, reveals something profound. Life is not a perfect mechanism. It is a dance of balance and chaos, where beauty and loss coexist, even in the tiniest drop of water. Though this marks the end of the story for this ciliate, it is only the beginning of the countless fascinating events unfolding on this channel. So, subscribe to make sure you don't miss the next video, a story that may bring a happier ending, or one dictated, once again, by the unpredictable rhythms of life.